topic for today is about half interval method. So the half interval method employs only 4 steps. The first step is to select two values, which we will assume for x, such that the function of x will result to a positive and another one negative value. The results derived will be the initial value for the x plus and the x minus, which we will be later be using on the HIM table. The second method the second step is to calculate the half interval or the x sub h for the equation. And to solve for x sub h, this is just equal to x plus the x minus, or the value that we have derived for x plus and the value for x minus divided by 2. And then we will substitute this value of x sub h to the function, and the following conditions. So after substituting the value of x sub h, if the value of f of x sub h is greater than 0, then the x plus or the next x plus will be equal to x sub h, and the value of the next x minus will be equal to x minus, or will retain the value of the same x minus. If the function of x sub h, or after substituting x sub h to the equation, if the resulting value of the function is less than 0, then for the next iteration, the value of x plus will retain. So x sub I plus 1 will be equal to the existing x plus, while the next value of your x minus will be equal to xh. Or if the f of x sub h equals 0, and then the root x will be equal to x sub h. If the function of x sub h reaches the specified tolerance for the error, you stop the iteration, and the last value of the x sub h will be the required root for the equation. So to fully understand half interval method, let us take this example. We are asked to find the root of the function cosine 2x minus 3x squared, with e, or error desired, should be equal to 0.0001. So following the instruction, or following the steps, the first step for the function, or for half interval method, is to assign two values such that your x will have a positive value and the other one will have a negative value. So here we have assumed that your x is equal to 0. So take note that the values of x here are arbitrary, or assumption. So good if in the problem it is already given. However, if it is not given, you are to assign values for x such as it will produce a value which is positive and the other one should be negative. So here in our example, so we assume at first at x equals 0, our function of x will be equal to cosine of 2 times 0 minus 3 times 0 squared is equal to 1. So the value here, so since this is 0 and cosine of 0 is equal to 1, so the value at f of 0 is equal to 1. So take note that this one, the answer is positive. Again, we will assign another value for x at x is equal to 1. So what if x is equal to 1? So function of 1 will be equal to cosine of 2 times 1 minus 3 times 1 squared. There the answer is negative 3.41615. And here take note that the answer is negative. So if these two values of x is not given, you are to assume or you are to give values for x such that the other one should be positive and the other one should be negative. Assign lang kamo any value for x nga dapat ang answer na one will be positive and the other one should be negative. Here, since the two values results to a positive and the negative value, the x which will result to a positive function can be used as initial value of x plus. So this means that since this is the answer here is positive, this value of x will become our initial x plus. And since this value answered or beared a negative answer, this one will be our initial value for x minus. So that is for step number 1. So take note, our x plus is equal to 0 and our x minus is equal to 1. So these are the initial values. So whatever is the value of x that you have assumed here, that will be your x plus and your x minus. The second step brings us to complete the table for HIM. So take note of the table for XIM. So we have here, the first column will be the iteration I. This one is x plus, this one is x minus, this one is x sub h. This is the function of x sub h, or the value of the function if we substitute the value of xh in the equation, and the last column will be the value of error. So here, we'll move this a little bit. For iteration 0, At iteration 0, what is the value of our x plus? Our x plus is equal to 0. Our x minus is equal to 1 because those values were initially determined, and according to our equation, the value of x sub h is equal to x plus our x minus divided by 2, because this is half interval. H means half. So that means 0 plus 1 divided by 2, that is equal to 0.5. So this value of x sub h here came from this solution. And we will substitute the value nga 0.5. So what is our equation then? Our equation is cosine 2x minus cosine 2x minus 3x squared. So we will substitute the value of 0.5 is equal to cosine of 2 times 0.5 minus 3 times 0.5 quantity squared. So that will give us negative 0.2097. So this is the value of x sub h. So take note that your resulting or the sign of the resulting function here is, this is negative. So when we say negative, the function is less than 0. So according to our rule in the previous slides, if the function is less than 0, your x plus will retain and your x minus will be the value of your xh. Again, we will write that here. If negative, if the function of x sub h is less than 0, your x plus n plus 1 will be equal to xh, and your x minus is n plus 1 will be equal to your will retain, this one will retain, so we'll retain the x plus, and here your new value for x minus will be xh. So that is the condition, since the value that we have derived here is negative. So in the next iteration, oh, by the way, solving for the error here is just equal to absolute value of x sub h. So this is just equal to, so regardless of the sign, since it is absolute value, 2097. So it is, this one is rounded off. This one is, I think, expanded, I mean. So we will now go to iteration 1. So take a look here. At iteration 1, what will be your x plus? We have mentioned that our value of x plus will retain. So what is the original value of x plus? That is 0. And what will be the value of your x minus? It will be now your xh. And what is the value of xh from the previous solution? It is 0.5. So again, these values were derived due to the sign of our previous solution. So x plus will be equal to 0 and x minus will be equal to 0.5 because of this condition, because of that condition. So solving for x sub h, it will be equal to 0 plus 0.5 divided by 2. Our x sub h will be equal to 0.25. So that's why we have 0.25 there. Again, if we substitute 0.25 to the function, it will be equal to cosine of 2 times 0.25 minus 3 times 0.25 quantity squared. That will give you this answer. Can see. So positive 0.690083. So take note, this one is positive. Our answer for f of h, x sub h, is positive. This one is positive. If your answer is positive, that means your function of x sub h is greater than 0 because it is positive. And if that will be the condition, we will go back to the equation again. If your f of x sub h is greater than 0, your x plus will become xh and your x minus will retain. Baliskad kay ina sa ina. So if it is positive, our x plus I plus 1 will become x sub h, and our x minus I plus 1, or the next I, will be equal to the previous x minus. So that will be the value of x sub h for the values of x plus and x minus that will be used in the next iteration. So So that's why you will notice here in iteration 2, our x plus, you will notice here that our x plus is the x sub h, the value of x sub h. Our x minus retained its value, and of course you solve for x sub h, that will be 0.25 plus 0.5 divided by 2, that is 0.375. And if you substitute it to the equation, it will result to 0.309814, and the error is just the absolute value of this one. So regardless of positive or negative, it will assume a positive value. And since again this is positive, so if the answer is positive, or if the answer of your function is greater than 0, you retain the x minus, and your x plus will assume the value of your x sub h. So that's why the x plus here is the x sub h of the previous. The x minus is still the same. You add this one and this one divided by 2, that will result to this one. Substitute that again to the equation, still positive. So x plus will be x sub h, and x minus will retain its value. So you will just continue to solve using the conditions given until you reach the desired error. So assuming that we have solved all the equation and we have arrived at the error required, the root, or the value of the root for the equation, is the last value of x sub h. And for this equation, or for this example, the last value of your x sub h, again this is x plus, this is iteration x plus, x minus, this is x sub h, this is function of x sub h, and this is the error. So the last value of your x sub h will be the value of your root, which is 0.453308. Again, the value of your x sub plus and your x minus in the next iteration depends on the value or the sign of your function x sub h in the previous iteration, considering the conditions set in solving for the root using half interval method. So just don't forget these conditions. These three conditions here are the most important one in solving roots using half interval method.